Hi everyone, Mike Sabocheck here, and welcome to SolidWorks live design stream. Glad you're with us today, and I'm broadcasting here from my home office in Fleetwood, Pennsylvania. And you're probably wondering where Fleetwood, Pennsylvania is, and it's right here in the eastern part of Pennsylvania.
Hi everyone.
About an
Mike
hour or
Sabocheck.
so from Philadelphia and a couple of hours from New York City. So you saw the invites, the pictures of my hot rod, and maybe I saw a picture of the part that we're going to be designing today. But I want to kind of describe to you what our design task is going to be today and the challenge that we have. And the first question I have for everybody is, do you know what you're looking at? So if you do, why don't you put that in the chat window here as I'm monitoring the chat window here on my other device. And I'd just like to get your opinions on what you're seeing, and I'll wait here a few seconds to get some inputs, and then describe, like I said, what our design challenge is going to be for my hot rod. Now, what we're looking at is actually the steering, the rack and pinion steering, and what we have here is the pinion shaft. So the pinion shaft starts right here. It extends itself into the rack and pinion housing, and it's supported by a couple of needle bearings that are internal to the housing, approximately here and here. All right. This tube over here, this is the rack. So the rack translates back and forth when I turn the steering wheel to obviously give me my steering control. Now, I needed to have this pinion shaft support that we see right here in the middle, this guy right here, because the shaft was unsupported out here and only supported internally on those needle bearings. And from about here to the end of the shaft is about 3 inches. All right, so a pretty fair distance. And what was actually happening was I was getting deflection out here at the end of the shaft when I turned the steering wheel. And what this caused was a little pause in my steering. So you can, you give it the steering wheel some input, but the car wouldn't necessarily turn until I gave it a little bit more of a turn, and then the car would obviously turn left or right as appropriate. So why don't I show the rest of my what I'm doing here? All right, here we go. Get this up here. So I'll describe that again. So as I said, we've got the pinion shaft here, and that pinion shaft extends itself through the rest of the housing. And I made this pinion support right here to support the shaft, because what was happening was when I was turning the steering wheel, I would get some deflection here at the end of the shaft. And that deflection, as I said, was causing me a little bit of a pause in my steering. So the steering wasn't accurate. It wasn't very responsive. So along with the support, I also needed to have a bearing. So I used a bushing right here, which is pressed into the housing. Now, I did obviously some work prior to, and I made up some sketches here of both the shaft and of the support plate. And then there was this little cap that was used right here that mounted right here over the opening of the opening for the pinion shaft, which included a little bit of an O-ring right here, which acted as a seal on the end, so prevented dirt from getting into the housing and affecting the gear. So our task now is to design up this housing, and when I was doing my sketching, I obviously used the appropriate tools here, okay, of a vernier and a machinist scale. This is not a ruler, but this is a machinist scale, and so we can measure things to like 10,000ths of an inch, get things fairly accurate. Now a little bit about my hot rod. Her name is Violet, and you probably could figure out why. She's a pretty vibrant purple color. And she's a 1931 Ford Model A four-door town sedan. So Ford made two versions of a Model A sedan, a two-door version and a four-door version. And so I have the four-door version, which has three side windows. The standard Model A had two. This is an original car, so it was made back in 1931, so she's coming up on 89 years old. And she's been a hot rod for about 50 years. I can trace back to when she was built. I know the builder of the car, and we had talked many times about the build of the car and what he did and where he found the car to build the hot rod from. I also have a magazine from 1975 that Violet was in. And one of my passions is just to work on cars. Not only do I just work on the hot rod, I've got another car in the garage, an MGB GT, that I put a lot of work into. So this is what I do on weekends during the wintertime when I can't be driving my cars. And not only that, maybe you saw over my left shoulder here a couple of pictures of my buddies that I race with. So my buddy Kevin here, Kevin Lee, down in Virginia, he and I should have been racing this weekend, but because of COVID, we can't, so we're stuck home. And then my buddy John Balhala, he and I used to race this Austin Healey Sprite for 12 years in the SCCA. So, my passion extends through all different types of cars, and I like to work on them, and SolidWorks is a big part of working on those cars. Not just my hot rod, but the MG, the race cars. So I do a lot of work and analysis using SolidWorks with these cars. Now, this is what we're going to be covering today, so I want to give you a little bit of a heads up to watch out for, some things. In-context design. This design right here lends itself really well to being an in-context design. So what is in-context? Well, working within the context of the assembly to help me design my part. Next, configurations to capture the concepts that I'm going to be coming up with. And not only just going to have one concept, I'm going to have three different concepts. And I have a mantra: any work worth doing is work worth saving. And I can save that through the configurations. Next, the property tab builder. Probably a little known utility within SolidWorks that helps me capture custom properties pretty darn easily using a tab on the task pane. And smart components. We're going to be using a smart component. That bushing is a smart component. And I'm going to show you how to build them. It's pretty easy. So again, doing something once, but leveraging it many, many times over again so that we're not having to do this type of work on a continual basis. So let's move over to SolidWorks here and let's get to work with working on our design. So like I said, I've already sketched up, actually not sketched up, but modeled up the parts that I'm going to need in order to design my housing or my support. So I've got the shaft and I've got the support plate. Now, if we just do a quick little measurement here, just to give me an idea of how long I need the support shaft or the support for the shaft to be, and SolidWorks is telling me that I'm going to need that's going to be 2 inches, from the face of the plate out to the end of where the housing is going to end. All right, so that 2 inches is going to be an important distance for me. So I've got a lot of information here to work with. So right off the bat, let's go into SolidWorks and insert a brand new part that we're going to use. And this part here will be called, I've already got one there, so we're going to make a new one. So I don't have to type very much out here. And then where are we going to orientate this new part within the assembly? And then we'll put it and orientate it to the front of the plate. Right? So we have, that captured. So my sketch is now open, we'll say, on the front plane of my new part. Now I'm ready to start sketching, but let's get rid of this hardware here. Notice I've got my hardware in a folder, so that allows me to quickly hide them and be able to manipulate them with, again, without having a very long design tree. Now, I've got some edges here that are going to help me start my design. Okay, so these 3 edges. Now, my question is, do I want to create in-context relationships between my new part and this plate? And I'm going to say yes to that question because this is pretty much of a one-off design, and subsequently I just want to be able to use these edges right here to get my design started. Now I've got full control over that, meaning I can use an option here to turn off external references. And so subsequently when I create my sketch, so for instance in this case right here, if I go ahead and turn that off, so let's turn that off, and I convert the edges that I've selected there, okay, into a sketch that's blue, all right? And we all know in SolidWorks that if I get a blue sketch, that means it's underdefined. Well, that's not really what I want, so let's get rid of that. And let's come back, let's turn our external references back on again, and I'll convert the edges again. And then I get those edges, and again, they're black, so it's telling me that I'm fully defined. Okay, cool. I'm just going to extend these arcs out here a little bit. I'm going to add a circle, okay, to kind of mimic the other ones here to this hole here. Wake up the center and drag that out just some distance because we're going to make it equal to the other ones here. Okay, equal to those two. All right, and because it's got a dimension, okay, we can get rid of that and obviously get rid of the arrow too. Okay, now I'll just add a line and create a tangency on both ends of that line. Double click and space to end that right there, and then we can just pick up the other one and again create another relationship down here as a tangency and coincident. Now we've got some additional geometry we need to get rid of here as far as the sketch is concerned, so we'll get rid of that guy, and we'll get rid of this one and get rid of this one. Now I might not have had, well, again, I've got to make sure that I got a tangency relationship right here between these two. Oop, wrong button. Okay, so we can finish this off pretty nicely. There we go. Okay, so my sketch is black. It's fully defined. But I didn't even use a dimension or anything like that to capture my design intent. Additionally, let's take these edges here of the holes and let's convert these into sketches also. So that now completes my profile of the flange that I'm going to use for my support. I use the S key a lot. If you're not using the S key, then why don't you try to use it, because it will cut down on your mouse travel and what you have to do. In essence, that S key allows me to access all of my favorite tools that I need to use when I'm working in SolidWorks. So I've got my first feature created. So let's move over and open up the part in its own window here by itself. All right, let's zoom in here a little bit. Now, again, good practice is to name your features as you go along here. So we're going to call that the flange. And I'm going to now start to do concepts on what I'd like my part to look like. So maybe the first concept that I came up with was just something fairly simple of a cylinder that will extrude out from the face there. We'll make it 1 1/4 inches. And again, we'll just extend this out. And again, we've got 2 inches. Now, the thickness of my flange is 150 thousandths, so my extrusion is going to be 1 inch and 850 thousandths. So all total, that will be 2 inches from the back to the front. Okay, so just a simple little extrusion. Now, the other thing we're going to need to think about is what we're going to, for instance, maybe I'd like to have some ribbing on this to maybe support it a little bit better, because again, we're going to be hogging the internal portions of this cylinder out in order to get the shaft through. So if we were to look at a front view here and look at the reference plane, so the top plane is going through there. Well, that's not a really good plane for me to sketch on, nor is this a good plane for me to sketch on. So really what I'd like to have is a plane that kind of bisects this face over here, or this edge. And that's exactly what I'll do. So we'll select this one. We'll create a plane. Okay, so I've got my first reference. My second reference is going to be the midpoint of that edge. And the third one is going to be the opposite side. And we'll grab that midpoint right there. And that will now create a plane perpendicular to that face and allow me to sketch on that plane. Okay, and we'll look normal to it. And we'll just create a line down here and end it there at the silhouette edge. Let's add a dimension. And we'll just round it up to about 1 inch and 600 thousandths. Okay. All right, so that looks good. So let's create a rib and just say okay to that. Now we're good to go. So we have our rib created. Now obviously one rib is okay, but I'd like to have 3, and the best way to do that is to just go ahead and pattern these around the cylinder. So we'll grab our feature, which is going to be the rib. The orientation or the direction is going to be my axes, and we'll go 120 millimeters 3 times. All right. So now we've got our part almost completed. One thing we could do back here is open up a sketch here, convert this edge to that edge right there, and then we'll use that as a cut, but we're not going to go through all because I need to leave some material to be able to put the bronze bushing in. So we'll go 1 inch and 350 thousandths, or 1.35 inches, and we'll just cut that material away. All right. Now, maybe the last thing I need to do here is round and fillet the edges. And so we'd like to have some smoothness here. But let's make sure that we've got our features named. We got the rib. We'll just call this the rib pattern. And we'll just say cut for shaft. All right. If I can spell correctly today. There we go. All right, so rounding and filleting. Now I can go ahead and window select all of the edges that we see right here. But I'm not going to do that. I'm going to let SolidWorks help me find the edges that I need to round and fillet. As I peruse through the selection filter right here, it's highlighting the edges that it will round and fillet. And then I just need to apply the size of fillet and round that I want. Okay. Probably got a couple edges in here that I don't need. I see what the problem is. When I created my sketch for the rib, I didn't get it completed to exactly where I wanted it to be. It needs to be up onto the edge up here. So let's create that pierce relationship. That's one of Toby's favorite commands, is that pierce relationship. Okay, let's go back to the round and filleting. Again, just select an edge. And we'll go grab those. There we go. Okay. Now this looks pretty good. Now maybe we could put another one here, but we'll leave it right there. Now, as I said, I'm going to create configurations here of my support. So we're going to call this concept 1. And then we're going to create another one while I'm here, and we'll obviously call it concept 2. And we'll move over to the other side. Now, I'm going to take all of the features for concept 1 and add them to a folder and call it concept 1. So I've got all of those moved over into that folder, neatening things up. And then I could take the folder and suppress everything in the folder. Now, my second concept, maybe I'd like to make it a little bit more fancier, right? As opposed to just a straight cylinder. So again, we'll open up a sketch here. And the first thing I'm going to do is we'll sketch up some circles that are just a little bit bigger than the edge of the part. Okay, so moving them out there. Come over here, do the same thing. But I'm not going to go ahead and sketch up the other ones. So let's actually make this one a little bit smaller. And let's just copy, each one of these circles. We'll just copy that one there, and we'll copy this one down here. Hopefully everybody knew that you could do that. So we'll just wake up the centers and drop these on to the centers. And then go ahead and control select all of the circles, and we'll make them equal. Right. And then we'll add another circle and make a tangent to the outside edge here. Okay, right there. Obviously I'm not going to sketch or I could select different areas here to extrude, but let's just go ahead and trim those away. Okay, so that's my sketch that I'd like to use. And we'll extrude this. Now, instead of extruding, we'll say, we'll say linearly, or we're going to add some draft to it. So let's add like 4 millimeters of draft. But you know what? I think that's going to be too small out here. So we'll leave it at 3 degrees of draft, not 3 millimeters. All right, but let's do a design check here on this face. I know the diameter that I need to have in order to put the bronze bushing in, and that's going to be about 88 thousandths. And I don't want to leave it just as that, so let's convert it over to construction geometry. Now, what I see here is I've got a lot of material here that really isn't going to be doing much for me, but I don't have enough material right here for the bronze bushing to get pressed into. Maybe that might even crack. And the other thing I really don't like too is the fact that this face right here actually gets bigger as it goes out because of the draft. And the other thing too is it's not really a constant radius because these are conical faces. So subsequently, this kind of looks okay, but I think I can do better. All right, so we'll just leave this as is. All right, and we'll put these two features into a folder, and we'll call this one Concept 2. All right. Now again, let's create one more concept, and we'll call it Concept 3, and we'll go ahead and add that. Now Concept 3 is going to be fairly similar to what we just did right there. So what I'm going to do is we'll go back into Concept 3, and first off we'll open up a sketch on this face here. And I'm going to just again borrow that sketch right there, so we'll convert it into a sketch in this on this sketch plane right here for the new feature that I'm going to be creating. So we'll extrude the same thing, but without draft this time. And what I'm going to do is go back to that plane we used for the rib and open up a sketch on that. Now, even though that it's suppressed, I can still open up a sketch on it. And we'll look normal to that. And I'm going to draw a line, again, from there, make sure I get my reference there correct. And then I can create that coincident relationship, and we'll just add an angular dimension from the edge of the cylinder over. We'll hold it right there. We'll make it 4 millimeters. Okay, good to go. Now what we'll do with that sketch is to create a surface from it. Okay, let's turn on. So let's just exit out of the sketch here. Show my reference. I'm going to show my grab my sketch there, make sure I got that, and want to show my axis of revolution. I should be able to shoot. Show my axes here. Well, let's put one in. So insert, reference geometry, put an axis in, that right there. Okay, so we got the axes that we're going to need. And grab my sketch again. Okay, and my axes of revolution, there we go. Okay, and then we'll use that surface as a cut. And make sure that we go in the right direction. We want to remove the material outside of that surface and not to the inside of the surface. There we go. And let's shut that surface off. Okay, so this is more what I'd like to have. All right, so this face here, now again, still conical, but it's not conical anymore, okay, because it's constant radius as we see right down here at the bottom. And then lastly, we'll go ahead and create our rounds and fillets on our edges here. Again, we'll just use that same face, and in this case here, we'll just grab some faces and we can round these guys all off right here. Just a different way of being able to select. All right, so we'll just go ahead and finish it off right there. Okay, So here's my part, almost finished. We'll just add that cut on the back surface here. And we'll convert that edge and create our cutout. But again, we're only going down 100 an inch and 350 thousandths, okay, inside there. Now, another thing that I had mentioned at the beginning there, the things that we're going to be covering today, and one is a property tab. So over here, we have the custom property tab. And this is going to help me capture properties. And I've got different property files that I can work with. So we've got a space here for a part number, so we can add our part number. Our description is going to be support, comma, pinion shaft, and who's it drawn by, and when did I draw it? Today. Is this a make or a buy? All right. If we switch over to buy, then my fields down below, they change accordingly. So I get vendor part number, and then the vendors. We have a list of vendors. You know, we can say these are certified vendors that we work with, but we're going to be making this. What's the material? Now watch in the feature manager design tree over here to the left when I change the material to 1060 aluminum. And the reason why this is getting prompted is because of the fact that we're going to be making a change here. And then what is the finish? Well, we can say it's an anodized finish. And also I've got another property here that's getting extracted, and that's the weight. So I kind of know how heavy this part is going to be. All right. And again, when I'm working on race cars, weight is a consideration that I'm always concerned about. Okay, so how did this property tab get built? How did I build this? So let's take a little diversion here and talk about that for a minute. And last thing I'll do here is just go ahead and save my work. Now, the property tab builder, you're going to find it if we scroll down to the SolidWorks listings here underneath SolidWorks Tools. Okay, over here on the left side, as we see SolidWorks Tools. And we want to go into that, and then underneath that you're going to find the property tab builder. So what can we do here? So we can open up, for instance, something that I've been working on. We have a property file here. These are files that get placed into whatever folder you want, and then system options, file locations. That's where you define where the location of these files are at. Now we work with group boxes. Okay, you have to start with a group box in order to apply whatever you want: text, lists, numbers, checkboxes, radios, and a list of groups. So here on the bottom, I've got my part number. I've got, you know, for instance, what is, you know, the number of pieces that we might need, a description. Well, maybe I'd like to have a little bit more. We'll add down at the bottom here, we're going to add material. Okay. And then the name from the list that we want is material. And I don't want to allow custom values because we only use a subset of materials, and I don't want somebody using some oddball material that we would have to go out and procure. I'd also like to have a text box. Okay, the text box is going to be weight. And this is going to be a property that we can extract from our part file. And it's going to be just a text value. Okay, so it's only going to be read-only, again, because I want this to be a one-way display, meaning that the weight is displayed and it can't be changed. We'll go ahead and save these off, and then I've got my file created that I can now create my my custom property tab and capture the types of properties that I have. And these properties show up here. Now, if I didn't have that, I'd have to come in here and add each one of these properties, meaning to come in here and to select what I want and, you know, fill out the values and things like that. So at least I cut down on the amount of work that I'm doing here by being prompted for the type of properties that I want. Okay, now that we've got our part finished, all right, let's come down here to our assembly, because the assembly is going to be showing the configuration that I originally started with, and that was concept number 1. So let's change this to concept 2. Well, actually not. Let's change this to, as we see, we got concept 2 there, and let's go back and let's change it to concept 3, because concept 3 is the one that I want to work with, and this is the one that I want to have manufactured. So as we see, everything is lined up beautifully. Okay, all of the holes are lined up. I'm, face to face here as far as the edges are concerned, and the part looks pretty nice. All right, I really like the way the part has come out. So we can now start to do maybe some other kind of work. All right, but before I get to a drawing, I need to put that bushing in. All right, so let's turn to our design library. Design library, I've got a folder here for parts, and underneath parts I have bushings. So I've got two bushings here that I've saved off. One is a bushing, bronze bushing that's got a flange on it, and the one we're going to use does not have a flange on it. I don't need a flange on this particular, in this particular case, because I'm not going to be, we'll say, having anything touch that flange. So I'm going to just simply drag and drop it out of the design library and drop it here in space. Right? Now, even though that my part has got a mate reference associated with it, I want to show you another way to mate parts together. You may or may not be familiar with smart mating. Now, what I'm doing is holding my Alt key down. I got my Alt key, pressed down first. I'm going to select the face that I want to create, in this case, a concentric mate. So I'll just hover over some other geometry that has, to be able to create that concentric mate. So again, pretty straightforward. Again, I don't have to use quick mates. I don't have to go into the mate dialog box. I don't have to do anything except for just selecting those two faces, and subsequently, and I just pulled it off. I can make sure that I get my coincident mate there, and so subsequently I've got this, the bushing right on the shaft. And then the second mate is going to be this face be coincident with the front face of the support. Okay, now, so what is a smart component really going to do for me? Well, if we look over here in the feature manager design tree, we see that the icon for the component has got a little lightning bolt through it. Well, that signifies that this component is a smart component. If I also click on the component, I also get a lightning bolt over here, and my tooltip says Insert Smart Features. So when I click that, I'm going to now go ahead and execute adding the smart feature, which is going to be the cut extrude. But I need to identify the reference. Now, this is important. When I go over to show you how we're going to create this, I'll explain the importance of making sure that we've got the right face selected. So I get a green check mark, so that is good. And then subsequently, we'll go ahead and execute and add the cutout, or in this case, the bore, for my bushing. As we see right here, okay, we've got our face right there, and now we've got, the hole is now created. Now, if I go ahead and we'll just, quickly hide the bushing, and if I double-click this face, I'm going to get the dimension for the bore right here, along with its associated tolerance, because the tolerance is fairly tight, and rightly so for this bushing, because obviously we don't want to over press it, meaning to have a lot of interference, because we might probably break it. So it's got to have the right size, and having the smart feature create that bore for me, I get that dimension, and I make sure that once I get over to a drawing, that is going to be included in the drawing. So now that we've got the part completed, let's go and do exactly that. Let's create our drawing. So let's open the part back up in its own window. We'll go ahead and make drawing from part. I'll grab my drawing template that I want to use. The C size should be more than enough. And then I'll drag in a front view and a right side view. And then obviously we always like to have our ISO views, and so we'll put him up in the upper right hand corner. Now, before I do anything else, the orientation of the front view is the orientation of the part in the assembly. And we'd like to make sure that this part is kind of, we'll say, squared up, if you will. Meaning that I would like to rotate this. So what do I have to do? Go back to the model and create some special view there, and then come back here and use that? Well, no. We can do this pretty much like we do in, we'll say, the part file, where I've got 3D space and I can rotate the part around in 3 dimensions. Well, here I've only got 2 dimensions, but we can do the same thing. We can rotate this view, okay, the right amount, okay, as far as the angle is concerned, and I measured that earlier, and we'll go ahead and apply that and rotate the view. Okay, maybe you didn't know you could do that. All right, so now I've got my views orientated the way that I'd like them to be, which is nice and neat, and everything is centered up. Okay, so maybe another view that I'll create, again using my S key to get a section view, and we'll come in here and I'll hit a tab key and reorientate that and anchor my section line down through the center of my part, and we'll put the section view up here up above. But the one thing I see is like, I'd like to have it flipped the other way. So let's flip the section line and look at it from the opposite direction. And that's what I can do right here. I can just double click on the section line and it will flip the view for me. Well, it hasn't yet. It's because if you see the cross-hatching here around the view, that tells me that it's out of date. So we can just do a quick rebuild and then flip the part the right way. Let's insert the model items that we used in the modeling, okay, the sketch dimensions and the feature dimensions. Now you can see they all come in here at the top view, and some of these maybe are applicable to the top view, maybe some of them aren't. All right, for instance, maybe we can keep the bore diameter there, but maybe some of these other dimensions they could be better used or better displayed in the right side view. So what do? We dimension these over again? Not exactly. So if I'm holding down my shift key, so just like a document in Windows Explorer, I want to move it from one folder to another. So I click on the click on the document, hold my shift key down, and move that document to another folder. And it's the same is applied here. Holding my shift key down, I'll drag and drop it over to the right view and then drop it in right there. Again, cutting down on the amount of work that I have to do to make simple little changes like this, so I don't have to redimension things over and over again. Maybe some other things that maybe you didn't know that you could do here. So for instance, if I just do that, I've got both dimensions on top of each other. And so what do I do with that? I will select both of them and come into this little window here that we get for dimensions and auto arrange those dimensions again and have them honor the spacing that we have set up in document properties. In this case here, they just put them in line because they work really well in line. Right? We can still keep our radial dimension up there for the fillets and the rounds. Here in the front view, maybe we'd like to put in some center lines. Okay, and then add some dimensions. We can use the center lines, to add our dimensions. And this little widget here allows me to place the dimension on either side of the view. Okay, so I don't have to, especially when I'm zoomed into a particular area that I'm pretty tight on, and maybe the dimension is off the screen. Well, I don't have to zoom out to place the dimension. I can use that to be able to place the dimension exactly where I want it to be. Okay, maybe some other dimensions, for the corner radii here. Again, I can use which quadrant do I want to place this dimension. We can add in our hole diameter here. Maybe we can add in a QTY of 3. Place that there. I missed the parenthesis, but that's okay. We'll put that back in. All right. Move this dimension out away from the section lines just for clarity. So we don't need a whole lot of dimensions because actually we're going to be using a CNC process to create the part for us. Okay, so we're not necessarily going to be using, but I'd like to have this documented anyways, just for clarity's sake. And then lastly, okay, we got our dimension here, our diameter dimension for our bore for the bushing. So this looks pretty good. Now, I'm not too concerned about the properties for this drawing because a lot of the properties are going to be coming from the actual part itself. So we'll go ahead and save this off. Now let's go back to our assembly. And we'll do some extra work here with the assembly. And we always like to have an exploded view of our assembly, okay, that we can put on a drawing, so we've got all of the parts, separated, and so we can balloon them pretty easily. So let's do that. But before we do that, let's actually I got a little bit ahead of myself. I didn't talk about how we created our bushing, our smart component. So let's do a quick review of our smart component here. Now, the bushing is in what I call a sacrificial part. This block right here has one feature in it, and that's two, meaning the extrude, but more importantly, it's the cut extrude. Okay, this is the bore that the oil-like bearing needs to be pressed into. And as you can see, the bushing's already got its smart features. So actually, I'm going to delete those, right? And we're going to do it over again. So here, let's go down, and underneath the tools pull down, we see we have make smart component, this guy right here. So let's go into that. Now it's going to be the smart component, that's going to be the bushing. We also have an area for components, and let me describe that a bit. Say for instance we've got an electrical connector that's got we'll say an odd cutout that needs to be put into, say, in a sheet metal chassis, along with 2 holes for screws. Well, we can put the holes in, as we saw here with the bushing, we put the bore in. But what about those screws? I'd like those screws to tag along with this smart component. And that's what the component dialog box here in the smart component property manager is for. So I can identify those screws as part of this assembly, as part of this smart component. So subsequently, when I put that we'll say connector assembly into a sheet metal assembly, I can then execute the smart components. It puts the holes in, and it also puts the fasteners in with me. So again, saving me work for having to do all of those extra steps. The feature that I want to define is going to be that cutout. Now, when I placed the smart component into the assembly, I had mentioned that the reference face that I selected was important. And the reason is because the sketch for that cutout resides on this face right here. Now, if I had, say for instance, inadvertently rotated the bearing 180 degrees and put it in, we'll say, backwards, and then I went to execute the smart component or the smart feature, it would give me an error. And that error was primarily saying, well, I don't find a face for me to put the sketch on. The face that you've identified is not in line with the sketch. So subsequently, that will give me an error. So just be aware of that when you create your smart components. We need to have consistency when we place them after we've created them. So that's why we're able to look at the features, get an understanding of what is comprised of this smart component, and we can also look at the face, all right, that is defining that smart component. So those 2 things right there are very important. Okay, so that's how you create a smart component. And again, they can be fairly straightforward, like the one we have right here, or you can make them complex with additional components like screws and nuts and washers and things like that. Okay, so we've got now our assembly fairly well defined here. So let's come in and let's show our hardware, because again, I want to include this in my exploded assembly. All right, so let's create, actually let's delete the one that's in there right now, and we'll recreate a new one, a new exploded view. So what do I want to explode first? Well, let's think about that for a second. How would I take this apart? How would I take this assembly apart? Well, I'm obviously going to have to move or remove the hardware. So let's get rid of the hardware first, so we can grab the nuts and the washers at the same time, and let's move them out to the left right here. And as you can see, we're actually exploding and moving the nuts and the washers apart from each other. Okay, that'll be my first step. My second one will be the bushing. Let's move the bushing out away from the rest of the assembly here. So let's grab that and put him approximately there. And then the last step that I'll do will be, we'll just move the housing out and put that approximately there. Okay, so this, oh, there, that was my, so actually let's go back and edit that. I had my finger on the escape key and I have inadvertently hit it. So let's do this one more time, just for practice, all right? So that's, you gotta watch where your fingers are at on the keyboard, otherwise you're going to cancel the work that you just did. So my bad. All right, so let's just move the nuts out a little bit and the washers out a little bit here. All right, so we're done with that step, and let's get this step back and move that bushing out to approximately there. And then lastly, we'll move out the housing, or the support, I should say. And we'll just bring him out, say, approximately there. Okay, hit the green check mark this time, not the escape key. And then we can also animate this, the collapse of the assembly, so we could use this even as assembly instructions if we wanted to. So just a cool way of being able to create a nice animation of our assembly here. Okay, so we've got our assembly created. So let's just kind of look over some things that we've done so far. All right, we've created our concepts. We went through 3 concepts for the support. We went from something fairly simple to something a little bit more attractive, as we see right here. We created our properties, or captured our properties. In fact, I'm going to show you one more thing about the properties before I leave the assembly here. And then, we came over here and we, assembled our bushing. We executed the smart features for it, so we got our bore at the right size, created our documentation. We started it, and we still need to do the assembly drawing yet, and we're going to do that next. And then, as I said, if we come back into the property page here, if I click on any of the components in this assembly, I get to view all of their properties. Okay, so no matter which one I'm selecting here, I'm able to look at and review the properties, even, for instance, a nut or the washer or the screw. So it doesn't matter which components that I have in this assembly. I'm able to view their properties without having to go into each one of the properties themselves, or each one of the components, and look at their properties. Okay, so we've saved off our work. Let's make a assembly drawing. Because on the assembly drawing, obviously we'd like to have a bill of materials. And that exploded isometric view that we created is available for me to just simply drag and drop into my drawing. Okay, let's shade it. It looks a little bit better. Next thing we can do is introduce a bill of materials. Okay, for each one of our components, we'll just use the standard bill of materials template. We'll put that up in the upper right-hand corner. Let's go into annotations. And we'll auto balloon all the components that are here in this assembly. Now, I don't know if everybody knows about magnetic lines for these balloons that we have right here, these annotations. So I'm able to manipulate all of the balloons that we see right here. I can even do things like pull a balloon away and anchor it back onto another magnetic line. And, reorientate my magnetic line to the way that I'd like it to be. Right? So something like this, extend things out. The spacing will be maintained for me, being equal. I don't have to worry about, balloons with their leader lines crossing each other, things like that. For instance, maybe this balloon right here, its leader would be better off over here onto, we'll say, that screw as opposed to the other one, so we're not kind of losing where it goes as it goes into the part. So just a lot of nice ways of being able to do that. Also, up here, we get a full listing of all of our components and their quantities. Quantities will always be maintained for me, no matter what. I can also even add additional views if I'd like to. So, for instance, maybe we'd just like to have an isometric of the assembly completely assembled. And we can have that as being, that shaded also. Or whatever. We can also put in, from type and and right side views, anything that we want on these particular drawings is fair game. All right, so we can go back and open up the assembly one last time, and again, admire the work that we've done. Okay. All right, so let's kind of recap what we did. We're coming up here close to the close of the hour. So we designed a new pinion support shaft, all right? That's a pinion shaft support. Excuse me, getting my words mixed up here. And that design was based upon, my existing parts, and also, again, modeling up those existing parts in SolidWorks so that I can use those as reference to create my new part. I used in-context design, and because again, this was a good case for an in-context design because this is a one-off part. I'm not too concerned about using that part in some other assembly, which may cause some, conflicts as far as the references are concerned. And again, you have full control over whether or not you decide to use in-context relationships or not. You can turn those things off as you go along. I captured the properties that I wanted using the property tab, and then I showed you how you could build that property tab and the interface for it using the property tab builder. So keep that in mind and be able to use that. And again, it's very easy to just drag and drop what you want and configure. And then lastly, we used a smart component, that bushing. I say, for instance, I use that bushing a lot. And just think how many times I would have to create that sketch, make the extrusion. Maybe I would get numbers transposed on, the critical dimension as far as the bore is concerned. So, again, I won't make those mistakes. I'll have that covered, and I'll always have the right dimension on the drawing as we go forward. So I'm sure that my colleagues, my coworkers, have been keeping track of the chat. I haven't been looking at it. I didn't want to distract myself with looking at it to see what's going on. And I'm sure everybody's answered whatever questions that you have. So I hope you enjoyed our live stream today of how I made my pinion shaft support for my hot rod, and you enjoyed what I showed you today. So thank you very much.